So the first major idea we did in this unit was the general solution. And this is the second major idea, and I have a name for these questions. I call them multi-revolution questions. Sometimes if you give something a name, and this is a name that I gave it, it's not like an official math name. Sometimes I give things names because if you have a name for it, then you'll be able to be like, oh, I remember the name of it, and because I remember the name of it, I know things about it. If I forget the name of it, then I'll probably forget some of the details. And again, this is going to combine some of the stuff with chapter 6, but add something new. Okay? Sometimes it's nice to have some steps off to the side that you can refer to later of what we did. So for this, I'll write some steps off to the side. Step 1, we're going to rewrite the domain for, and I'm going to put this in quotation marks, because it's going to change depending on the question. Like our question here says solve sine, and inside here I'm going to highlight it. It says there's a 3x inside. That's what's new about this question. We have a 3x inside of sine instead of just a theta or instead of just an x. So that's the new part. And what we're going to do is step 1 is rewrite the domain for 3x. So I'll write the steps in blue, and then beside it here, I'll do the question. So if the domain for x was between 0 and 2 pi, what would the domain for 3x be? Okay? And this is really a simple idea of, if I got you to pick a number between 1 and 10, you'd all pick a number between 1 and 10. And then I say, times it by 3. Does it make sense that everybody's numbers is now between 3 and 30? They started between 1 and 10, and then I said multiply by 3, and they're like, well, now my numbers are between 3 and 30. So if x is between 0 and 2 pi, and you multiplied it by 3, does it make sense that 3x's would be between 0 and 6 pi? Which is, on the unit circle, 0 to 6 pi is once, twice, 3 times around. Multi-revolution questions because you're often going more than once around your circle. Okay? 2. And again, I'll put this in quotation marks. We're going to solve for 3x over its domain. So my question was, sine of 3x equals 0. Well, if this was one thing, is sine ever 0 on your unit circle? Well, that's our y-coordinate, right? And it would equal 0 at 0, pi, and 2 pi. So normally, this is where students, the number one mistake where students make mistakes is they stop there. They say 0, pi, and 2 pi, which is correct. But the domain for 3x is you have to go 3 times around. 0 pi and 2 pi is once around. The second time around, I would have 3 pi and 4 pi. And the third time around, I would have 5 pi and 6 pi. Does that make sense? Oh, the textbook does this, and I made a tiny, tiny little mistake. Can anyone see, based on the question and what I wrote, what my tiny mistake is?
You included 6 pi, but it's smaller than.
Yeah, I'm going to take out my eraser here. Notice that there shouldn't have been an equal sign there. right? Because in the original question, if I take out my highlighter here, notice that they included 0, but they didn't include 2 pi. This is extra mean. It's like, come on. So that 6 pi is not actually part of my answer because its actual domain should be between 0 and 2 pi, but 0 is included, but 2 pi is not. And then, now that we've solved for 3x over its domain, step 3, we could easily solve for x. What would you, if you had 3x equals pi, and you wanted to solve for x, do you see that you'd have to divide by 3? So if I want to find what x is, I have to take each of my answers and divide them by 3. I simplified the 3 pi over 3. Are you okay with that? To just pi? I divided all of my answers by 3. And notice all of our answers now are between answers are exactly what we wanted originally. They're all between 0 and 2 pi. But we ended up with 6 answers. Normally, how many answers? Normally, we find like 2 answers, right? Once around the unit circle. Usually, it's in 2 quadrants, and you get 2 answers. Sometimes the axis family is a little bit different. But we ended up with 6 answers because it was a multi-revolution question. Then part B. Part B is asking us to write out the general solution. So if you look back in our notes, we wrote down something about the general solution yesterday. If something asks you to find the general solution, you first solve like normal between 0 and 2 pi, and then write down all the coterminal angles to each of those answers by adding 2k pi to each one. Those were our instructions for general solution. Does it change with multi-revolution? No. We can do exactly what we were doing in our multi-revolution question. Did we already solve between 0 and 2 pi? Yes. So if I wanted to write my general solution for x, I can write out all the answers that I had. 0, pi over 3, 2 pi over 3, pi, 4 pi over 3, and 5 pi over 3, and add 2k pi to each of them. All 6 of them. And define that k belong to the integers. And we have our general solution. So a multi-revolution question has those 3 steps are very helpful. Rewrite the domain for whatever you're solving. Solve for that over its domain. And then divide to find your final answers. So we'll do another question like this. See, you have space. You can turn to page. You maybe do it on 576 or 577 if you've run out of space. So first thing I notice, inside the cos is a 2 theta. Probably going to be a multi-revolution question. Can I get the cos by itself? Yes, I could move the 1 over and divide by 2, and I would get cos 2 theta equals 1/2. Same as if you would solve for cos. You would try to get cos by itself. At this point, is it a calculator question or a non-calculator question? Is 1/2 an x value on your pi plate? Do you remember your reference angle? Yes. That's going to be your pi over 3 family. So, okay, but it's a multi-revolution question. Step 1, rewrite your domain for 2 theta. If 1 theta is between 0 and 2 pi, does it make sense that 2 theta is between 0 and 4 pi? Step 2, solve for 2 theta over its domain. Well, we know that it's a pi over 3 family. And cos is positive, so we would look in quadrant 1 and quadrant 4. But this is only once around the circle. And for 2 theta, how many times do we need to go around the circle? Twice. How do we find something coterminal with pi over 3 the second time around? Does it make sense that you would have to add 2 pi to it? And you're going to get really good at adding fractions in this unit. Because if I add 2 pi, but I need it over 3, what would it be over 3? 6 pi over 3. If I have pi over 3 and I add 6 pi over 3, can you see that you would get to 7 pi over 3? If you have 5 pi over 3 and you add 6 pi over 3, you would get to 11 pi over 3. Do I have to keep going? No, because this was, the first 2 was the first time around the circle. The next 2 are coterminal the second time around. So again, what's nice about the multi-revolution questions is they practice our idea of coterminal angles. How do you find a coterminal angle? You can always add or subtract 2 pi. And if I'm adding things together that are fractions, I need a common denominator. Now that you've solved for 2 theta over its domain, divide everything by 2. Dividing by 2 is the same as multiplying by a half. So dividing pi over 3 by 2 is like multiplying by a half, which would just multiply your denominator by 2. You'd get pi over 6. And if we keep going with that, this will be 5 pi over 6, 7 pi over 6, and 11 pi over 6. And all of our answers now are between 0 and 2 pi, which is what the question originally wanted. Okay, so circle question number 10.